Okay, so we're proving it by induction, okay? So the first thing we need to do is show true for n is equal to 1. Now, n is a positive integer, so we're only showing it for natural numbers, okay? We have to prove it true for all natural numbers, so that would mean natural starting at 1, okay? So that's why we're showing it true for n is equal to 1. So cos theta plus I times sine theta to the power of 1 is cos of 1 times theta plus I times sine of 1 theta. Okay, so that's just cos theta plus I times sine theta equals cos theta. So that is true. Okay, then we need to assume a true for n is equal to k. So just replacing n with our k. Okay, and then the third one, we need to prove that it's true for n is equal to k plus 1. So anywhere I have k, I'm just replacing it with k plus 1. Okay, so on the left hand side we have cos theta plus I times sine theta to the power of k plus 1. Okay, so I'm adding my powers, that must mean I was multiplying before this step. Okay, so it's cos theta plus I times sine theta to the power of k by cos theta plus I times sine theta to the power of 1. So let's write that out on the left hand side. And that's equal to this over here. Okay, you would write it all out in an exam. I'm just not going to here at the minute, okay, but you are writing the right hand side out each time. Now, come back here. I have assumed that true, okay? So there's my assumption, cos theta plus I times sine theta to the power k is this, okay? So we're going to replace that cos k theta plus I times sine k theta. So this is what's happened. I've replaced this with this. Okay, we assumed that to be true. Multiplied by cos theta plus I times sine theta to the power of 1 is just that, okay? From there now you're going to do first number, second bracket, second number, second bracket. Okay, so we write it all out, cos k theta, first number by the second bracket, and then second number by the second bracket. Okay, so what we have now is cos k theta by cos theta. Let's just write that. Cos k theta cos theta. Then we have cos k theta by I times sine theta. So plus I cos k theta sine theta. Here you have I times sine k theta cos theta. And here I sine k theta by I sine theta. I by I is I squared. What's I squared? Minus 1, isn't it? Yeah, lovely. So I by I is minus sine k theta by sine theta. So this is what I have. From here you're going to put your reals together and you're going to put your imaginaries together. So I'm going to keep these two together and I'm going to factorize out the I, and I'm going to put these two together. Okay, and we're going to end up with the identities like we did in trig 2. Okay, so cos A plus B, sin A plus B, or something along those lines. So let's have a look at what we have first. We have cos k theta cos theta minus sin k theta sin theta. Just putting those two together. Anything without the I goes together. And then we have an I, okay, outside of cos k theta sin theta plus sin k theta cos theta. Okay, so I just factorized out the I there. So I'm just going to my log tables now, and I have here, this would be cos A cos B minus sin A sin B. So I'm having a look here, cos A cos B minus sin A sin B. So I know that this part here is actually cos of A plus B, cos of k theta plus theta. Okay, and over here I have cos A sin B plus sin A cos B. Cos A sin B. So it's going to be this one. Okay, now if you think about this, I have my cos and then my sine, okay, and then cos and sine. So I just have them swapped, but that's okay. All that's going to change is, let me see, sine of A plus B. Yeah, it's actually still going to be the same thing, theta plus k theta. So we'd still be able to just rearrange it. Okay, so I'm just going to get rid of the first two steps up there and we'll keep going with this. Maybe to there. Okay, so we said this part here is cos of A plus B. Now my A is the k theta and my B is the theta. Okay, so you're just going to replace that there with cos of k theta plus theta plus I times, and down here, if you want in this step, you can rearrange it to be sine theta cos k theta plus cos theta sine k theta. If you want it to look exactly the same, but it's not necessary, like this is a proof, so they know you know how to manipulate this. Okay, so that's sine of A plus B. Okay, so that there is sine of k theta plus theta. And the last thing you're going to do is you're going to factorize out the theta out of that little bracket. Okay, so you're going to have cos, and theta is going to come out and you're going to be left with k plus 1. I times sine theta is going to come out and you're going to be left with k plus 1. Okay, so I've just factorized out the theta there. Now I think at the beginning we had it that The k plus 1 came first, so let's just finish it off by writing it exactly like the right hand side. So just swapping the k plus 1 and the theta's place, that's totally fine because everything, like, they're being multiplied in there. And that's what I had on the right hand side. And now you need to say, so it is true for n is equal to k plus 1. Okay, so true. Etc. So it's true for all values of n is a natural number, or down there, if you wanted to go back to exactly what the question said, true for all positive integer values of n. Okay. Totally up to you.